As a complement to the super data application, which is used for data acquisition, plant-wide supervisory control, and data acquisition, we have a load entry application. The load entry application really complements your plant-wide visibility by providing you with additional data capture and recipe management, as well as historical information that can be used to report on existing runs, historical runs, as well as operational performance. What you're looking at on this overview screen is a representation of what a plant overview would look like, giving you a quick view into the status of each particular piece of equipment. You can break this down by different areas, so I could have different departments, so each department would actually get a view that was specific to them. And on this screen, what I have is each piece of equipment, giving me a status with some indication relative to the process variables, the data points that we're logging, or some of the data points that we're logging. These are all customizable, so they could be different for each particular furnace or application. And I also have different status indications that are represented by colors. I have a quick view into trend data. So the SD Recorder Pro application is directly launched from each of the particular furnace applications that I have defined here. I also have indications that are defined for what we refer to as gap times. Gap time represents a reason code for downtime between loads. An operator would be responsible for identifying what that gap would be before they load the furnace. In this example here, we had racking that was defined. Maybe prior to the load, we did not have proper fixturing or there was additional work that was required. So before I could load that, I would identify what that gap time was. Gives me an opportunity at that point to, before I start a load or add data into my load entry system, to identify what that gap would be. That can be extremely useful when evaluating plant performance and looking at information from a historical standpoint to identify opportunities for more labor, maybe more equipment, more fixturing, etc. Just to expand on the information as far as the data capture goes for the different gaps, it's one of the setup parameters, and there's a number of setup parameters that we'll talk about. But just to look at what we're referring to when we discuss the gaps, these are user defined. So you can identify any information here relative to what is applicable to your operation, whether it's a power outage, a furnace survey, a system accuracy test, calibration, generator maintenance. It can be anything that you define. And you create these gaps so that you can utilize that as data capture. And they are all, of course, set up in advance. The gap times can be used or not used depending on the operation and whether the customer feels it's appropriate to utilize that information. So once we've identified that I have a gap time that's defined, you'll see the reason codes. Of course, these are all the ones that we just looked at in the setup. And I can identify furnace maintenance, I can identify furnace survey. So before, again, as I illustrated before I actually start a load, I would have to capture that information to display it. So the information that once I have that, now I can report on that. So from an operational standpoint, when I go to my historical tab, I have a couple of reporting options, one of which is gap time. So you'll have furnace utilization, you'll have gap time, and you'll have load tracking. Just taking a look at the gap time is going to be based off of the start, the from and the to time that's identified here. Once I've identified that and I hit the run report, you'll see that I can look at either a specific furnace or I can look at a group of furnaces. I'm going to look at the entire group that we were looking at before. And what that's going to give me is it's going to provide me with all of the information about the gaps between the June 1st and the June 23rd, breaking it down by the percentage of time associated to each one of those gaps. It also gives me utilization. So I have a quick view into my active and inactive time associated to that time frame. And then based off of that inactive time, I have a breakdown of the percentage of each of those gaps. I also have the ability to look at that information on a shift-by-shift basis. So you can really slice and dice the information and the data to provide you with more information to make better decisions when it comes to the operation. So before we go into full use and operational information associated to the load entry, let me just touch on a couple of the setup parameters that get used for the load entry system. We already talked about one. We talked about the gaps and how they would be utilized. Furnaces, of course, are going to represent the information that you're doing data capture on, possibly using the SSI super data system. These furnaces are going to be defined with information related to how we're doing the data logging, whether it's a programmer or non-programmable, so recipe-based instrument. There's also going to be some associated information about the types of operations. Operations could be a grouping of different types of processes that are performed in that department or on that particular piece of equipment. Using a simple view of brazing and carburizing, draw temper, or FNC nitriding, it can kind of draw a good category of how that would be looked at. For each furnace, I can define how it's viewed on that front and overview screen. So the IQ line might be on the overview as well as the IQ department, as an example there. And you get to define really the user experience using this information in the furnace editor. Along the lines of user experience, for each particular furnace, this is where I can define what gets displayed to the operator. So you have display line 1, 2, 3, 4, and then the process variables. So I can include different types of data. Maybe I'm going to include customer data or part information or estimated completion time. And then I can have that particular piece of data with a specific color associated to it if I wanted to identify things with different colors. And then I have the process data. So the process data is what I'm actually capturing from that piece of equipment. So it could be temperature, it could be carbon, it could be vacuum level, it could be load thermocouples, it could be anything that I'm performing the data capture. So when I have that information, again, it's really taking that particular piece of equipment, defining what specifically how I want that viewed here, the data points, the areas that I would actually associate to, and then of course the operations. So along the lines of the operations, when we look at the different information that you can define within the system, you have an opportunity to define parts as well. So we can turn on the parts database. So the parts database allows me to associate all the parts to specific operations and how those operations would be performed, and really actually go right down to the specific recipes that would be used for that part. So you can see here that I have different part numbers that are named on this display here. When I have that part number, I can have data capture associated to some details. So anything that I see on here could be a user-defined field. So I could capture the material type, I could capture the thickness, I could capture customer-specific information if I wanted to. So when I look at the information associated to that particular part number, I have the operations that get performed on it, as well as the recipes. So I could really slice this up so that particular part just has one recipe but it might be one recipe per operation, for an example. So that's where some of the setup information is. And not everybody will use the parts database. I can turn the parts database off and just allow the operator to capture the part number upon entry of running that information, which is pretty common to see in a commercial heat treat shop, for example, unless their process people or their setup people are actually going to create the part numbers, which would be then allow them to associate the sequences or steps that they would perform on that part as it goes through their particular operation. So I mentioned the term sequence. Sequence is really the steps that a particular part would go through when you create that. You can assign a sequence not just to part numbers, it could be assigned to a work order. So as work enters the building, maybe I'm not doing data capture for a part number, but I want this sequence. So I want to go through a wash, a harden, and a temper process. And when I assign that sequence, you give it any name that you would like to provide that name, and you are going to assign the steps. And the system will then keep track of the steps that is required for that particular job to flow through the facility. And of course, you can see here where I have these operations, I also have recipes associated to it. So for this particular sequence, I can define step 1, step 2, step 3, and actually go right down to the recipe number where they would be pushing that recipe into the controller and execute that as appropriate for that particular part that's making its way through the facility. So taking the concept of creating work for the plant and how it's going to work its way through the system, when I come over to the active tab, this tells me the status of different work orders that I have floating through my facility. I have color indications here for parts or work orders that are ready, that are in sequence, and that are in process. In sequence means that I might be operating on a current furnace, and then I have a next operation. So just like we looked at as far as creating a sequence or steps that a work order would flow through the facility. So it's really the workflow there. So looking at that, let's just go through and illustrate how you would create a work order that would be going through the facility. So I could scan an existing work order that comes from an external system, or I can actually create the paperwork that I want to use as this work makes its way through the facility. So I can identify information here, and a lot of this data is going to be used for data capture, so I can report on it later. And you can define what type of information it is that you want to capture at the time of creating work or creating a part. So it's all customizable, set up by you in advance, and then you can define what's required and what's not required. So when I have the opportunity to add a sequence for a particular part, I click on the add sequence. So if I have a part that's coming in that's a specific material type that I know how to run all the way through, or maybe there's only one option as far as that sequence goes, I can assign it. So for that particular part, I actually have 2 different case steps that are defined just in this illustration. I specify the total quantity. I associate the 3 steps that it's going through. If I needed to add another one, I could certainly do so. Once I hit the save button, that work order now gets created, goes into the ready status, and is available for me to make its way through the system. I have the job created, so my parts and my work are set up to run through the facility. What I can do is actually generate a traveler that goes with the paperwork. And when I go through and double click on that particular work order, I could have already have printed this, but when I select the print button here, it'll give you the framework of the work and where it needs to make its way through the facility, giving me the operations that are required. And it could be specific to a furnace. If I'm the setup person and I've identified what furnaces it should be worked in, then I can define that there. That might be based off of furnace classification or some specifics or operating parameters around the furnace. But you'll see here that I have a barcode that can be scanned by the load entry system, both from a workstation or from the mobile application. So you can use an app on a smart device. And then it'll give me some basic information about that work order. So to illustrate how this works, on that work order there, the next operation that I have is the wash. The wash right now has a gap of furnace maintenance. Once I'm going to start to run there, I simply hit the save and start. Now in this scenario here, the wash does not have anything associated to the recipes. This is just an operation that's non-recipe based. And here I have my information, so I can scan that as I mentioned, and that scan could come from a mobile device or simply from a screen, just like I'm doing here. And what I'm going to do associated to that information is hit start load. It says that it's going to run this manually. So what that will do is create the beginning of the time that this load was in that particular piece of equipment. And so you'll see here that my piece of equipment now shows that I have a load in there, the time in, who it was started by, and if there was a recipe running, it would show you the recipe information, similar to what you see up here. But because the wash is a manual process, not run with recipes, that's what's being displayed there. So the example of scanning at the piece of equipment illustrated here, I have my traveler making my way to the equipment, scan using the load entry system, recipe starts, and I'm on my way. After scanning at the equipment, I have my status, so it shows the work order, when it was started, estimated completion time step. Of course, we saw that was all customizable. Single click, I get down to the details. So on any furnace, if I'm running a load, I can take a look and see what customer it is or what other information that's relative to my operation. And then, of course, I have visibility from here directly into the recipe that's running. This happens to be an SSI 9205 controller that's running a recipe. I do have a recipe control block, so I can, in this example here, I have the ability to do some advancing or some adjustments to this. So there are some recipe controls that you can allow or enable in your system. So now on my particular piece of equipment, of course, I am operating it, and I can see that the status has changed to step 6, estimated completion time. So that is the concept around getting visibility to my current overview. And then I can look at the active, and it'll show me that the job is still green in process. It's showing in the current furnace with this second step of the sequence that we looked at. And the next step after completion, of course, I have the estimated completion time on the screen as well, but you can see that I have the next operation of the draw temper. When we look at the actual controller itself, just to illustrate the process here, I'm using the TS Manager program that comes with all 9,000 instruments, and I can see here that recipe is running. If I click on the recipe button on the controller itself, so this is emulating what's actually on the controller touchscreen, I can stop the recipe. That would mean that it's run to completion. So it's either going to run to completion, or I can manually stop that. Once I perform that stop, my status updates accordingly on the overview. So the work is now completed in the batch furnace. The next step, I could go to my temper line work on the particular draw furnace, for example. And by the way, everything is user and password protected, so I have responsibilities to log in at different levels, which provide me access to different information. So as I click here, so the draw furnace is in a ready status, which means that I have to assign a gap reason. So in this case, there was no parts to run in the furnace. Waiting for work. I could put information on here from a note standpoint, so I can go back and do some research around reasons. But here on this screen, whether I do it from the mobile app or from here, I'm simply going to scan. So this is a scannable action where I can select the actual job or traveler that I'm working with. All the information is already displayed here. Here's the recipe that's associated to that work order, which is associated to the part, which captures customer information. All of the recipe data is here. I simply hit the start load button. That pushes the recipe into the instrument, starts the process on the controller, and that is now on its way into a status of completion. On my active screen here, I would see the current furnace with the current operation. So that it's a good point here to just kind of talk about the history. So I have this history screen, which gives me an opportunity to go back and review data that I've captured with the load entry system at all kinds of different levels. I have a dynamic filtering process here, which I can search on, and it's going to search all the details of the data. This might be customer name. It could be the material type, for example, so I could enter a material type in there. So if I've done any data capture around a piece of information where I'd want to get a list, and you can see that the list gets associated to whatever I'm typing in there. If I clear that out, then it's going to give me all jobs or loads between those two points in time. And you'll have information on here. I could sort by time in, I could sort by time out. So it gives me dynamic filtering based off of the information on the top. I could search on a specific furnace. I can search on operation. So it gives me plenty of information here that gives me an opportunity to really do some research. But what you would be looking for is you take a particular job that I might be interested in, and I want to see the trend from the time that it was in the furnace. So I simply click on the View Trend button. It pulls up the SD Recorder Pro application, and now I have all of the data associated to that load. And of course, I can turn data points on and off. I can drill down and look at particular points in time, and I can do all the things that I have the opportunity to do with the SD Recorder process data. So it gives me all the details of the data on there. So it's a quick view. So if I look up a job number, I can get that information quickly. I have the ability to generate a load report. I can turn data points on and off on that load report. I can include trend data or raw data or both. And if I had multiple work orders, I might choose that I only wanted to include one work order. Maybe you don't want to share customer information on your final report that's going to your customer. So as I hit the print button, again, since we know the time that it went in the furnace and the time that it came out, which is all based off of the recipe, if you're using a recipe programmer, I have that information here and all the details associated to the load. In summary, the load entry applications used for capturing load data, customizable by you. It's a recipe database, it's a part database, and the whole goal here is to provide quick access to historical information, operational statistics for reporting, and of course make a operator-free environment so loads get run properly on specific pieces of equipment, running the right recipe at the right time.